Algebra page 6, page 34. Looking at this system of equations, we can see that there are no additive inverses for the coefficients. That makes it difficult to use the addition to solve this system of equations. But we can multiply one of these equations to make an additive inverse. So we really have to look at both and what would be easiest to multiply everything by. That means every term in the equation that would create an additive inverse. Well, we see here we have this positive y, we have a negative 5y. So the additive inverse down here for the positive 5y, it would be a negative 5y. Is there an easy number to multiply this term here to create a negative 5y? Actually, if you just multiply it by negative 5, that would create the additive inverse. So let's go ahead and multiply this top equation by negative 5. We'll rewrite it down here. So negative 5 times 2x, because you have to do it to each term, plus negative 5 times y, and then negative y multiplied by 3. So let's see how this resolves. This is going to become negative 10x, because it's 2 times the 5, the negative 5, that's 10. So negative 10x, and then this is going to become a negative 5y. Negative 5 times y is just negative 5y equals negative 15. Now that you have additive inverse, you can use addition to solve for this. So let's write this bottom equation right below it down here and then add them. So 7x plus 5y equals 21. We'll plus both of these together. This becomes negative 3x. This just cancels out, is 0. And then the other side of the equation is 6. So we'll write it neatly right below it. Negative 3x equals 6. We can isolate the x by dividing by negative 3. You have to do it to each side. So these two negative 3's cancel with each other. So you're just left with x on this side. And it actually resolves to x equals 6 over negative 3 is negative 2. So we know x is negative 2. Let's go ahead and figure out what y is. We just need to plug this negative 2 back into one of the original equations. Let's try this top one. It looks like that one's pretty easy to plug stuff into. So negative 2, so 2 times negative 2 plus 2y. Actually, that's not 2y, it's just y. My fault. So just plus y equals 3. So this becomes negative 4. Negative 4 plus y equals 3. Plus 4 to each side. And then these two 4's cancel out, so it's just y left on the left side. Y equals 7. Now that we have that, we have an ordered pair. You have for the x coordinate, -2, and then for the y coordinate, 7. So there's your ordinate pair, your ordered pair right there. And to check it, why don't we plug these both into the bottom equation to see if it all resolves out right. So 7 times -2 and then it's going to be plus 5 times 7. So plus 5 times 7, and that should all equal 21. Is this in fact right? So this is -14 plus 5 times 7 is 35 equals 21. And this actually does turn into 21 on this side. So 21 equals 21. It checks out. This is the right answer, and you've solved this system of equations by addition, and you actually had to create your own additive inverse, and you just did that by multiplying one of these equations by a number that would create an additive inverse between either the two y's or the two x's. In this case, it was the two y's. We created the additive inverse.